now let's get started with chapter 4. Chapter 4 is actually for masters. Okay. Chapter 4 is for master and testing. Okay. And master is actually a function. And master has nothing to different from function. But let's talk about function first. You know, in computer science, you probably hear something called procedure. You hear something called subroutine. You hear something called function, and you also hear this name called master. Okay, and all of these actually means same thing. It's just a name for different stage, I should say. Okay, the first name is subroutine. Okay, well, the first name for a function is called subroutine. What is subroutine means? It actually original is routine. So instruction one by one, we keep running. That's a routine, right? That's actually a table. That actually is a table, right? So that's a routine. I'm sorry, I don't know why I hit it. Just call. Let's call a routine. So routine is something that you keep going. So it's like a timeline. You try to do something one by one. And subroutine means you go somewhere and then you jump to there and then go back. That one is called subroutine. So originally, the subroutine name is something like this. Okay. And later, people say, oh, it actually quit. So this one, subroutine sometimes is when the people use the line number 10, 20, 30, 40, or call segment to remember the line. It actually is subroutine. And later they say, oh, this is not good. This actually is not really professional. So that has a different name. So that's a different name. They call it procedure. And then at the time they use a procedure, they start to have a function, procedure name. Say P of something, and then some parameter. They start still jump to somewhere else, but actually they have an idea called procedure. And then you need to save the location you take off, and then remember to return back to it. So that it should start to have the idea of so-called context switch. You need to change the environment for the environment variable. So then there's a procedure. And then later it becomes something not only jumping, you need to return something, and a while or something to return it. Then it becomes a function. Okay. And later, because of object-oriented programming, you get some number, some return value, and also it is considered part of the member of a object. So we start to use the name method. But in fact, all of these 3 or 4 different names means the same thing. It's just a function or a sub-program that you go to run it. Okay, but different stage they call it differently. So that's so-called method or subroutine or function. Okay. So usually function means something you have returned, just like the function it is. Okay, this one we call it a function. And procedure means you call something, but usually it means there is no return. Okay. And subroutine actually doesn't do context switch. You just jump to somewhere and then go back. But in fact, these are similar. Okay. And then method is the name for Java or any other object-oriented programming, because method belong to a certain object. Say circle. Say I have a circle, and I have a get area for that circle. That become a property of a certain object. We call it method. So in Java, we always call it method. Okay, even if it is a function or something else, we always call it a method because it belongs to a certain object. In that case, it belongs to a certain object, and then we call it method. Now let's go to start a class. Okay, here we have a class. So let me call this guy circle. Okay, I have a circle, right? So here I just clean up everything. So the first method I write is actually called static allegory main. This one is a method inside this circle class. Let me remove those comments. I don't need that. And this one static. And if you forget to put that, actually it passed. Okay, if you don't want to get the system variable into your program, the string bracket args is not necessary, but I just put it there. Okay, that this is a simple function we have belong to circle, but this one is a static function. This one is a static function. Static function also called class function. Okay, it's a certain property for that class. So here I can have like say I can put int a equals 3, int b equals 4, and then I say system.out.print. Okay, and then I clean up everything. This one, and then I bring out system.out.print line a plus b. This is actually quite simple. It's just a normal main function, nothing special. And then you print out the data we want to have. Okay, that's simple. But this actually is not really the purpose for discussing the method, because it's only this main function only have one purpose. It is the entry point for the program. Okay, it's the entry point for the program. But actually here let's see. Here I may have a circle, right? I may have a circle, and then I would have, let me see. Let me see here. I can actually I can have a public static get area. Okay, and here I return double value, and here I can have a double radius. Okay, and then I return mass.pi times radius times radius. Okay, and then I calculate it. So I run it. Sometimes it takes a while. Oh, I did not bring it actually. Sorry. So here, let me say this one. Let me say actually get area of A. Okay. Okay, you got the area with a circle of radius of 3. Okay. So this one actually you put in the number 3, right? Put into get area and you calculate. Go to here, do calculation, and return this value for you. Okay. So here, what I want to say is this one is called the method or function over here, right? So this guy get area is the function's name. Okay, and then double radius, this we call it parameter list. Okay, sometimes this is also called formal argument. This is called formal argument. So it's actually a name list. We call it formal argument. And then this one A, this one A, the value is 3, right? We put a 3 in there, and that 3 matching the radius. This 3 matching the radius, we have the radius over there. And radius, we call it formal. Radius, we call it formal argument. and this 3 we call it actual argument. So it's the number we put into the function, we call it actual argument. And the variable that is matching that number is called formal argument. Okay, so a function has a name, has a parameter list, and parameter list we call it formal argument or arguments, and then the value that put into there is actually called the actual arguments, and then the double we call it return type. Okay, that's the data type you will return to the outside world, and then static and public, both of them we call it modifiers. Public actually is for the public is for visibility. Who can see it? Public is for visibility. Static is to differentiate whether it is a class method or a instance method. Okay, so this a little bit complicated, but it's the whole thing that we see right here. The first one, public, I repeat again, is called visibility. And you have public, you have private, and you have default package level visibility and also protected. Okay, so there are 4 different levels of visibility. For the time being, I don't want to go into so much detail because you cannot remember everything. But once we are in the chapter 9, I'll repeat this again. Okay, so remember the public is only for visibility. So you will see some function is a public, some function have no public, and it doesn't matter at this moment. Okay, so don't worry about it. This one is a visibility. Now the second one, static, is static. It's a class variable, class method or instance method. Okay, today I'm going to discuss this. Okay, so later you will find out what is static, what is non-static. Okay, so this one we'll discuss it. It is a class method or instance method. We'll discuss this. And then third one, double, is return type. Return type is the type you will return to, just like your y equals f of x. The y is the data type that you will receive the data from this function. So that double is the data type that you will return. So that's the return type. And then the next one, get area, is your function name. And then the next one, double radius. Radius is an argument, or we call it parameter variable. Okay, and it is in parameter list. And parameter list has another name called formal argument. And then you put in 3 in there, and then the 3 called actual argument. So actual argument is the number you actually pass through the function. Okay, so it's a little bit complicated, but it's just what we write here. That's what we wrote over here. Okay, so also remember this part from double to this parameter is the name, return type, and the parameter type. This is also called method signature. It's also called method signature. But method signature is to identify a method. So say right here we have this one called get area of this, right? And then right here, let me actually print something. Let me print before we print return this one. Let me say print system.out print line and say I am in double. Okay. And this guy, let me just copy once. Okay, and here I have the same. If I don't change anything, the signature is the same. So 2 identical functions, no, it won't work. But here I change the double to integer, and then there's no warning, right? So here, let me see. I have this integer a equals 3, right? So let me change b to double. Okay, and then here I copy this guy. Again, pass it, but I change it to b. Okay, and then here actually this one was integer, so here I say I am in integer. Okay, so I actually get area A that is the integer, so I should run this guy get area with the integer radius first, right? Even though it returns the same value. And then I will go to this guy get area B next, okay? Okay, so these two have the same name, same return type, but different parameter. We say that it has different signature, okay? It's just like my name's Eric Chia, but another girl called Erica Chia, but the first name is different. That's totally different person. Okay, so signature make the difference as well. The parameters make difference as well. So the first one, I go to this, it match the data type. It said that this is a integer. So the actual argument 3 match the integer type. So you call this one, come to here, print out I'm integer, return the pi value, come back, print out. You've got 28 something, right? The second one, you have to get area B. B is a double. B is a double, so actually, I'm sorry. B is a double, so B actually go to this, this one, the first one. And then you print out I'm in double, and then return the value is a double value, come back, print it. It becomes 50 something. Okay? So a function can have the same name, but different parameter type. It's okay. Actually, they are two different functions. Okay? And there is a name for these. These two functions called overloading. These are overloading functions. Okay, these are overloading functions. An overloading function means the same function but with different parameter type. And they perform in the same way, but you need to handle different data type. Is that okay so far? Is that okay so far?
Yeah.
Okay, so this one is the first concept. I talk about the parameter, talk about the name, talk about the signature, talk about the overloading function. Okay, that's the first part we cover by this. Now, actually this is good. Okay, this one is good. Now the next one I'm going to discuss is, okay, I promise you I'm going to discuss the static and non-static. Okay. Now let me see. Here, if I say here I'm a circle, right? So I write down I'm the radius. And say I'm radius 1.0. Okay, set to the 1.0. If I declare a variable over here, oh no, integer cannot be 1.0. So let me change it to double, right? And then I say it's actually 1.0 is fine. And then I say here I have a static integer number of circles. Okay, and here one has a static, one without a static. Okay, and right here I say, okay, let me do this. I say system out the print line, and I say let me print out the number of circles. Okay, this guy compile and run. Oh, it's okay, it's 0. Actually, okay. Now let me actually print out system.out the print line, and right here I put radius. No, it won't pass. It cannot be accessed. And I click Control K. It says non-static radius cannot be referred from static context. Oh, I cannot use non-static. So here I have to be static in order to have it to run. But well, what's the difference between non-static and static? Brendan, you know that or no?
No.
You don't know this?
No.
Okay. So the difference is what?
Because the doubles implemented or printed out a correct number, but the what is it, normal one, the integer, only printed out like 0 or like it rounded down to the nearest rounded down to the whole digit.
Yeah, that's actually the integer division problem. Yes, but yeah, but this one is different. This one is the difference between static and non-static.
Oh.
This one doesn't pass the compiler at all. So it's a different problem.
Yeah, never mind. We did a different thing.
Yeah, that one you talk about is integer division. I know, but it's not related to here. Here it actually is a so-called static and non-static. Okay, keep watching. Okay, I'm going to explain it. Now the first thing you need to know is that there is a function called with the same name as the class name. Here we have a circle, right? I can put a circle, but no return type. There is no return type. Okay, this one have no return type, and I say double R. And this double R, this one is a function, but it's a special function. Okay, and right here I say my radius equals the R. Okay, this guy is called constructor function. It's a constructor. What is a constructor? Constructor is the BO a circle. So let's take out this guy. Okay, let's take out this guy. And right here I say circle C1 equals new circle. So we used constructor before, like scalar input equals new scalar. That is a constructor. Okay. Here we have a different constructor called this one circle. So I create a circle and then C1 and C2 equals new circle 2.0. Okay, and right here I won't have my this static number of circle. Here I say number of circle increased. Okay, now I call it circle twice. Okay, and I print out system.out.println, and I put my C1 dot radius. Okay, and I will also print out my C2 dot radius. Okay, and I copy these two, so I can twice, and here I say C1 number of circles and C2 number of circles, and then I copy one more time. This guy actually is C2 number of circles. I change it to circle number of circles. So here, let me see. Here.
Wait, is circle its own type of class?
Yeah, don't worry. Okay. This one C1's R equals. Okay. So this one I change it to C2's R. Okay. This one C1, I use the C1's number. Okay. So I change it to C2's number. This one I change the number. But I will say it's class class number. Okay, so let's run this one. Okay, we run. Let's look at the result. Okay. So here, actually, what happened is, okay, right here. The first line we create a circle. Okay, so we create a circle. We create a bigger circle. The radius is 5. And we create a small one. The radius is 2. Right? And then when you see that its radius, oh, that's actually 5. C2's radius, oh, is actually 2, right? 2.0. And C1's number of circle, oh, actually you see a number of circle. That's 2. And then, oh, you see a number of circle is also 2. So when you say it's static, it's a sheer copy by the whole class. When you say it's static, it's a sheer copy for the whole class. So I have a circle class. I build a constructor. So every time I actually call it circle, I increase my number of circles. So when I use the constructor once, I actually has 1 circle. When I use the constructor twice, I have 2 circles. So this number of circle keep track of the number of circle that I have created. So I put it as static. And when you say it is static, it belongs to the circle. It doesn't belong to any instance circle 1 or circle 2. Circle 1 or circle 2 is a real circle. And circle is a class. Circle 1 or circle 2 is objects. So here has the concept of class and object. Class is a template. Class is a template used for copy something else. Class is template. So I use the template class circle to copy for a instance C1 and this instance C2. And these are 2 real circles. They have different radius. But my template, my class circle, I keep track of the number of circle there. So even there is no circle, I will have my circle of number of circle right here. When I put it here, the number of circle actually is 0 when I print it. So initially, when I have no instance, I have no circle 1, circle 2, I still had a number. The number is 0 because I haven't created anyone. So that variable number circle is steady. It belongs to the class circle. That's called class variable. And the radius is called instance variable. So instance variable belong to the instance, belong to the circle. Doesn't belong to the circle class. That's the difference between a class variable and instance variable. And also, class variable exists when you actually loaded the circle class. But the instance variable doesn't exist until you actually create circle. You will have the radius. That's why when your static function try to print radius, that radius cannot be printed because there is no circle. There is no circle object, so there won't be any radius that I can print. But the number of circle exists even though it's 0. It exists because that belongs to the circle class. Is that okay so far?
Yeah.
Okay so far?
Yeah.
Okay, so 2 kind of variable. One is called class variable, one is called instance variable. Instance variable belong to instance, belong to a single instance, or people call it object. Okay, when you say object oriented, actually the class is used to generate different circle object. and each circle has its own radius. But when we talk about static, static belong to the whole class, whole class. So we will see like circle that number of class it will work. But the rule is instance function can access the class variable, but static function can only access static variable but not instance. Because when static function exists, those actually the radius may not exist or may not be able to differentiate. So now we have this circle constructor. Now let me put a function called public and then double and then get area. Okay, I have a get area again. Okay, and this get area is different from the static function over here. So it actually is a totally different function. So here I return mass.pi times radius times radius. Okay, and then you will get the area. Now let me do this. This one doesn't belong to the whatever radius you put in to calculate it. Okay, so here is the way you run it is actually.
I think you have a timer thing.
What? Pardon? What's problem you have?
Oh, I think you have like a timer thing.
Yeah, I know. I'll stop it later. Okay. Okay, so we have the R1 equals 5 and R2 equals 2. Okay, so let me compile and run. So you will see that the get area have different area. Okay, let me clear the timer. Okay, right. Hello? Hello? Is this okay so far?
Yeah.
So you see the difference between this one actually is instance method. Instance method belong to the circle itself. And that one is get areas is trying to calculate the area of some other circle with the radius. So this one we also call it utility function. Okay, we sometimes call it utility one. This one we call it instance function. Okay, then let me generate another type of function. It's still static. Okay, it is still static, but here, let me put it here. I don't get this one double. I get this one as a circle. Yes. And this one I actually call extra radius. So this one actually I get the area for subcircle that as a parameter I put in. Okay, this method doesn't belong to any circle. It belong to the class actually circle class. It belongs to the circle class. It doesn't belong to any instance C1 or C2. This one, just like the other two, the double radius or integer radius, This one also belong to the class. So we have three static class functions. Okay, so right here, let's try. Let's try. Let me copy these two. Okay. So let me actually test it. Okay, in here, instead of using get area, C1 get area, I put C1 here, C2 here. Okay. What's wrong? I delete one curly brace. So let me actually put a U here. So no, again. So I know this is by the utility functions. I use good. Okay. So these two actually, these two functions belong to the class. It's a help putting together to help people to do functions. Okay, these are called utility class, the utility function. You know, we use some function called like mass dot power before, right? Or we do mass dot abs absolute value, or we do mass dot random. Those kind of functions. These are all utility functions. All belong to the mass class. Is that okay? And this one actually get area 1, 2, C1, C2. This one is also a utility function. All the three static functions are utility functions designed to help other people to calculate. So now let's run it. Okay. It actually compile pass and then I run it. Okay, and you say I'm in utility. Okay. So let me actually remove that I'm in utility. So we know that already. Okay. So here, and you may argue, oh, here you actually say that static function cannot access instance variable. No, actually you pass the circle as a parameter. So I know it's circle S. It's circle S. So you at the runtime you give me a circle, right? Even though my function is static and you load it in the memory master area, but you give me the circle, so I actually know that it specifically is this X circle. It's not something else. It's not like in main function I just put the radius. Then actually I don't know who's the radius. I don't really know what radius it is because there is no instance generated yet. Here you already specify some. You already specify some circle. That's fine. That's actually absolutely fine. Okay. So now I can actually do one more instant method. Let me call it equals. Okay, it's a Boolean method. So let me say here other, and then this one is another circle. I try to compare two circles, my own circle and other circle. Okay, here return. I try to return what this radius. If radius equals others dot radius. My radius is the same as the other guy's radius, then two circles I think is the same. Okay, so here let me do this. Let me generate a C3 circle. So I change it to 5, okay? So C3 circle. And here that actually let me copy and paste. And here I say C1 equal to C2. Okay, and then I say C1 that equals C2. Okay. And then here I copy this one again. And I put it here. And I say C2, I'm sorry, C1 equals C3. And then I compare C1 to C3. So here, when I call it when I call this C1 equals C2, my radius belongs to C1 because C1 is the object that call the circle. So radius belongs to C1. And then this C2 actually is the other circle. So other circle's radius, that's 2.0. Compared to 5.0, that's my circle. My circle C1's radius. So 2 are not equal. So this one should return false. And the other one, I have the C3. So actually, I have my C1's radius 5.0. My C3 is the other circle. So other circle's radius is also 5.0. So that should give me a true. Okay. So this is another instance measure. This instance measure get area, and this one get area without parameter, and this one equals with a circle other. These two are actually the parameter. The instance measure belong to some circles, and other with the static, it belong to the class. Belong to the class, it will provide utility function. Okay. Now let me do this. Here I can put something called test circle. Okay. I can put something called test circle, and then, oh, I don't like to put static over here. Let me just cut it. Okay, let me just cut it. I cut this everything out. Okay. Put to the test circle. Reverse whatever garbage it has to here. Okay, and I really don't like my command side. Remove that. Okay. Number one, you see this test circle has a new arrow pointing to circle. That means my test circle use the circle. So that created relationship of these two classes. These two classes has a relationship called use relationship. Sometimes it's called has a relationship. Test circle has some circle, has a circle, or has some circle. That's the has a relationship, also called use relationship. Test circle use the circle. And these two classes, okay, also can be viewed like this. My circle is a circle class, right? And I use that circle class to generate C1 object, C2 object, C3 object, right? And this one actually is my circle class. Okay, it's a data class. Data class with 3 objects, okay? And the other one's test circle is circling it. We call this a test class. This one is called test class. It provides a signal to test it. Sometimes we also call it test bench. Okay. Sometimes we also call it test bench. What is the test bench? Test bench actually is an electrical engineering term. So if we go to a certain website, we just type test bench. So test bench is actually a table that you use to test some electronic devices. Okay. So this is a test bench. This is called a test bench. You do soldering and changing component, trying to test it like this, a test feature, trying to test some data like that, okay? And this is automatic tester. Those are called test bench. Similarly, in software, we have a circle. We have this test class trying to give stimuli or data into the software, try to test it. We call it test class. So here we have one data class, one test class, and the test class sometimes also named as driver class. You use the driver class to test the data class. Sometimes it's also called driver class. Okay, to test the data. Is that okay so far?
Yeah.
And we do see some error anyway, right? We do see some error anyway. So here, oh, I'm sorry, I made a first mistake. This one is is a class, an instance method should belong to circle. I actually cut it in the wrong way. Put it back, okay? That's number one. Number two, here, no error. Oh, okay, this one, oh, my number of circle. No, the number circle is available in here in the circle, right? It's a class variable, but when other class are trying to use it, there is no way to know which number of circle it is. So in order to print that one again, I need to use the class name. Because it's a class variable, I use the class name. So that class name actually is accessing the class variable here. What is a class variable you used before? You actually may have used this one, mass.py. That one is a class variable, a class constant, 3.1415 something. Okay, that's the class variable. So you use the class name, that the variable name. Here the same thing, the class circle. I want to know about how many circle has been tested so far, created so far. So I say, oh, give me the number because the number is stored in the class circle. Okay, that's the class method. Okay, and here I put these three. So these three methods actually belong to test circle if we put it here. So because it's in the same class, so I don't need to put test circle that get area C1, C2 if I'm using the static method like this. Okay, so let me compile and run. Okay, but this get area method actually, well, it is actually more suitable to put into the circle. It's just like math.random or math.abs because I want my circle to have the utility function to serve other class who want to use me. So let me cut this one, put back to my circle here, even though it doesn't belong to any instance. But actually, you provide good service for other people who want to do calculation for circles. So let me put it here. Okay, so this one I compile is passed. But the test circle now, oh, we have trouble because I don't have a definition for this area now. So let me actually put this. So in order to get those class method or utility method, I need to put the circle that here. That's the class method back to here, so that I can access those class method, static methods. So static method when accessed by other class, you need to have the name for the class. If it is accessed by the same class, no, you don't need that. You actually have the access to that already. But this one works just fine, just like it is actually in here. And with that class name, if I am happy, I just copy all these, cut all these, and I throw back to here. Oh, I'm sorry, I cut the wrong one. So if I actually here, let me see that. Let me cut this main function, put back to my circle. With that class name, with those class name over here, this one actually just work fine. That's the same as you put in that other class. And usually, if this one actually, if you want to test it, you can just cut it here and then just throw back to here. Two will work exactly the same. Okay, both work. It will work out just fine. See how I'm doing it? So the main function actually is only helping to do testing, providing the so that actually this main function help to do what? It's like a test bench, right? And my circles, class, and object are here, right? And this guy just try, oh, set up 5, put it here. I'm sorry. The main function's job actually is just my data is inside here, right? And its job actually, oh, I have I'm trying to, okay, I put a 5 to the circle 1. I put my 2.0 to the circle 2. Oh, okay, I create another one. Something like that is actually helping the cell sim to test it. Okay, so that's the function of the main function. And you can actually put this main function in another class or in the circle class. It doesn't matter. The only difference that it will make is that if you put into different class, you need to specify the class methods and name. Otherwise, you cannot see, oh, okay, where is the get area? I don't get it. Okay, where is the get area? I don't get that area. Is that okay so far? So that's the issue when you do testing, okay? That's the issue when you do testing. And if you put into different class, you run it with the same, almost no change. Okay. So this actually, I think I have a very clear introduction for the static and non-static method. So non-static method, we call instance method or instance variable, belong to the object, a single object circle. And the class static one belong to the class circle. So class circle, if you want to use it by other class, you need to use the class name. The instance method, you want to use it, you need to specify which instance that is calling it or on the data. Okay? Is that okay so far?
Yeah.
Yeah.
Okay, so this is very important, okay?
But can you go back to the circle one again?
What?
Can you go to the circle one real quick?
Circle one?
Yeah, the circle tab. Like this is the circle tab.
Okay, circle class. Yeah, okay.
Can you go back to the test circle now? Wait, why did you do the C1 and C2, C3 dot C?
Let me put into two class. Okay, what's your question now?
Like, why did you do C1 dot radius? Like, why not just do C1?
C1 the radius?
Yeah.
I'm putting out this data.
Oh, never mind. Oh, you're inputting it in there? Never
Yeah,
mind.
yeah.
I see it.
Is that okay?
Yeah.
Okay, now I have probably almost done with the content here. Let's browse through chapter 4. It said method and testing. Actually, I covered testing already. Now, first one we talk about mass method. Okay, so mass method we have mass dot square root. So this one, what function this is? Is that an instance method or static method?
Static.
So it's a static utility method, and we call the name class mass to calculate the square root of 17 for everybody, right? So that's one. Angle is a data, and height is a data generated by this. So this science is also a static method belong to the mass class. Okay, so you calculate the angle. Probably the angle is of what radian unit. Okay, so 1.5. Are you okay with radians?
No.
Okay, how about Brendan? Are you okay with radian and the degree, right?
Yeah.
So the value of trigonometry function has the sine, cosine, and tangent. Must be radian. And if you did not radian, you have to convert radian to degree. Okay, that's fine. Okay. And then pi is of capital letter. It actually is a what? It's a constant defined in mass class. Constant is also a kind of variable, but it just you cannot change. Okay. And then so when we access it, we call it mass.pi. And E is the natural exponent. Ethan, you know E, right? Epsilon,
Yeah.
epsilon, right? It's Euler's number epsilon.
Yeah.
2.781, okay?
Something like that.
Okay, that's fine. So this pi is fine. So this probably you guys are fine. Composition, just like the methods composition, functions composition. Are you okay with function composition?
Yeah.
Are you okay?
Yeah.
So actually, you will calculate the value for sine and then compare to that. That is called function composition. This is not really hard, so we actually just do whatever composition is. Okay. Now the next one, define a new function. Define a new function is also easy. You just run you define a new line, and you will print first line, and then new line will print the empty line, and then just this one is also easy. Okay, so that's fine. New line, that's fine. Flow of execution. So flow of execution, we started from this function, and then once we go to this get area, we'll jump to get area. And as I said, you will check the data type here to find the best match method. Okay, in this case, A will be integer. You will go to this, integer one, right? And then copy to here, and then B, you will go to radius. Okay, that's fine. So you will work out fine with this. So that's the execution flow. You have to follow execution flow one by one. And then the next one, parameter and argument. I talked about it already. Parameter also named as the formal argument. And argument means real argument. So a row is a argument. And then the string str, that's a formal parameter that is actually matching the real argument arrow. Is that okay? So here, print twice. This one actually is a actual argument, and string s is a formal argument. Both need to match, and then if it match, s actually holding the address for this print out twice. So that's good. It's easy. Okay, this one's okay. It's called parameter pass. When we pass the parameter, we pass some value to it. In this case, it's a string, so we pass the address or hash code for string to this function print twice. Okay, that part is fine. And this is also one. The next one I'm going to talk about stack diagram. This one is important. Okay, stack diagram is important. So I will use a whiteboard to explain it. This one is very, very important. Okay. So what is stack diagram? What is stack diagram? Say here I have a function called main, right? And I just make sure. So here has something inside. Here I just ignore it. Okay. So if I call a f function fy, say, and then equals g, okay, something like that in the middle. So there's a stack, and I put here. I have a frame. This is called frame of main function. Okay, so this variable is called g. So I have a g variable over there. When I call f, it will actually stack up a f frame, a frame for f function, and actually, so for here, if I have f integer x, right, something like that, and here I have local variable t, say, equals x. And then it will be a local variable t, and that s is called a parameter. It will be actually put into the frame as well. So there's a parameter s. So g will copy the y. I'm sorry. Here it will have a y. Y will copy the value to that variable s and put into the function. This is called a stack diagram. Okay, this is called a stack diagram. So let's look at something from internet. Let's call it a stack diagram. So now you can call it stack diagram and you say Java code frames. So this shows you the code frames. Okay, let me try to find a good one. This one? No, this one not good. Let's see. It's probably C language, but it's fine. So when I have a Java stack, right? This one. So I call my function main function called f. F will have different frame, and f frame will call, say, g function. It will have another frame. Okay. So that's fine. So here it is. This one probably show better. Let me show in the new tab. Okay, this one's better. Okay. So here I have a main method, right? My main method has a called M1. So M1 called M2, M2 call M3, M3 call M3 do something. Okay, so my main function put lowest in my stack. So originally these three not existing. So originally these three not existing. Okay, so originally I only have this main function, and when I call M1, so actually it will create this M1 class. It will create this M1 class call friend for me. So there are some local variable we store over here. Some parameter from the argument will be stored here. Okay, and then M1 call M2, M1 call M2. I'm sorry, that's M1. M1 call M2. M2 will have its own call frame over there, and a call frame will still store something. Number one, the parameter you have. Number two, you have your return address. Where should I return apply finish the function? Third one is local variables. So store these three information into a frame. Okay, and then this method 2 called method 3. So method 3 stack up, right? But once you finish method 3, sorry, method 3 is gone. So my frame from method 3 gone. And then, okay, and then I finish my method 2. So method 2 is also gone, right? And then, okay, M1 done. Okay, and then I only have main. And then once main finish, everything got cleaned up. Is that okay? This is called call frame. And diagram you see quite often. And in fact, this chapter has 2 homework. You need to write your own code stack. So I don't want to tell you what it is. You just work on the homework. You'll see there are 2 problems. Exercise 3 and exercise 5 both has the state diagram. So draw whatever you can draw for me. Hand drawing is okay, and then try to send by email, scan in, okay? Scan in to me, that's fine. So that's the so-called state diagram. So we finish this state diagram. Return value, I talked about it. If you put a void, that means no return value. If you don't put a void, actually you will need a return type, say absolute value, it need to return a double type. So you will take over by another variable. So that's the return value. This one I think is easy. Okay, so when here we have a main function, right? We have a diameter 1.0. We calculate 10.0 divided by 2. This 5.0 is the actual argument. The actual argument you pass to the formal argument radius. So formal argument double radius actually is a variable. We use that variable to calculate the area, right? And that area after finish, you have a return function, a return operator that will return the 78.54 back to here, assigned to this area and print. Okay, that's the calling process. This is called passing parameter. Passing parameter basically copy the value of it to the radius. And the radius is the same as a local variable you see on this one. Actually is also just like a x, just like a x defined in here, the same thing. And this radius is alive for the lifetime of the function calculate area. You can use that whenever this function is in power. But if you are of it, the radius will become, because it actually live in the call frame. So there is a radius. And then once you do calculation in this function is fine. But once it's gone, the function done, it will be evaporate. It will just disappear. So you no longer have that one. So this is called a parameter, and parameter is also one kind of the local variable. Is that okay? Any question about this local variable and parameter? Okay, the next one is incremental development. Okay, incremental development. Okay, the way I do my program is incremental development, right? You see me develop the circle class one by one, right? I do it pretty much an incremental way of doing it. And then I try to put my test class inside, outside, right? Try to show you what it is. So eventually I have a test data class, I have a driver class, okay? That's the incremental development. So try to have a goal, what you are, so basically start with working diagram, making small incremental changes. At any time, if there's an error, you will know where it look at, right? So I write a program, I do have some error, but you will be able to handle if you do it bit by bit, okay? And use variable to hold intermediate variable value to check it, so sometimes I print out I'm in integer, I'm in what, right? And you can hold some variable as well. So those I'm in where actually helping people to understand where I am. But in fact, in real program, I should actually comment that out. Okay, that's debugging message. Shouldn't be, okay, shouldn't show up for the customer. Otherwise, it's not professional. How comes I'm in circle, I'm in double? It's not professional, Okay, that actually look better, So if you are working for a company and you say, I'm in the party, okay, you're in trouble. So you need to comment those comments out, okay? And sometimes if before we develop some function and we still don't have the function yet, okay, I can develop something called stop. So here let me try to create a stop for you. Okay, I will get area. So here if I say public double get parameter, the circumference, okay, parameter, right? And I don't have time to write this, so I just return 0, right? I have no time to write whatever it is. I'm bored today and I don't want to continue to write any program, right? And but my boss still want me to test something, right? Then what I can do is that I create something called stop. Stop is something fake. Something replace some real one. Okay? Something to replace something real. That you can, oh, okay, my boss doesn't check my data, I still get it through. Wait, this one actually, sometimes this new version of the project has a problem. You need to click it or something to get a newest update. Is that okay? This is called stop. So some people may write a southern line in order to get this one, but for me, I just return the suitable data to make it work in a way that nobody knows that I'm cheating. That's called stop. That's something just to make it work. Okay. Try something. Okay. Distance. Oh, okay. I put a return 0.0. I don't want to do it. Okay. I don't have time today. But usually I write many things just stop. Return 0. Return null. Return something. But I have all the function name ready before I write it one by one. Now, actually, it's a good habit. Okay. At least your program doesn't break down if you don't have the right information. And later, you can put those code into there to finish it. Okay. To finish it. Okay. That's for our chapter 4. And then you try to do, if possible, do all the exercise. Is that okay? And then number 6 probably a little bit difficult. Number 6 probably a little bit difficult, but you should try. Okay, you should try. Any question for me for today?
I won't be able to do like until Thursday, or maybe on Friday.
That's okay. You are excused. Whatever you have time. We probably will meet on Wednesday. Okay, but you can do it weekend or some other time. You know, I know you are away, not at home. So just try your best whenever you have time. Okay.
Okay.
And any question for this semester and testing so far?
No.
So today actually I give you a good example of whatever instance variable, instance method, and all kind of methods, right? So you should actually one way is that download the code. I will send it today, okay? These two circle and this circle to you today. But you should download it or get it or even print out. Read it line by line, okay? That will be the best way to understand what it is, okay? And I'll try to finish the video as well. Okay? If no question, bye now. Is that okay?
Bye bye.
Bye now.
Bye bye.
Bye.